Hello everyone, welcome back to Ronnie Explains. So in this video, I'm going to take you through the process of designing a gray code decoder. So we shall have a quick look of what a gray code is. So if you look at binary numbers, for example, if you are having some input values here, uh, let's say you have 0 and then you have 1, and working in 4 bits you have them up to 15 like this. Then this other side you have uh, the equivalent binary codes like this, and here you have 1 like that. Then I just copy and paste some few things here like that. Then this here represent the binary equivalent of these decimal numbers. So I can give this a color, for example, like green, and I name them from this end as A, B, C, and D. And this other side, so here I will call these ones binary numbers. And this other side, I can also merge these cells here and call them now the gray code equivalents. I will center it, and then I also name these ones here as A out, B out, C out, and finally D out. And how to determine a gray code is by using XOR gates. XOR is a gate that shows a true value for different inputs. For example, if you have here some pairs of binary bits, here you have 0 and then you have 0, then here you have 0, 1, then here you have 1, 0, and finally here you have 1, 1. Then for XOR gate, this is how it's going to play out. So it shows true values for different inputs. In this case, the inputs are the same, 0, 0. Therefore, here the output is not going to be 1, but it's going to be 0. And here we have 0, 1. Those ones are different inputs, therefore the output is going to be 1 because it's going to be a true value representing different inputs. Here it's also the same case as the second one, so here it's also going to be 1 because the inputs are different. And finally in 1, 1 the inputs are the same, so the output is going to be 0 because it is showing that it's supposed to be showing that these ones are different, but in this case they are the same. So this here is how we generate the outputs of an XOR gate. Then I will create 4 kernel maps to represent these values that we have here as output values. So I will have a 4 variable kernel map like this, give it some borders and merge some few cells. So I'll merge this cell here, I'll merge that, I'll merge that, and I'll also merge that. Then I'll just give them the variable names as A, B, C, and D. Then I will bolden everything and align it towards the right, like that. Maybe I will give some border highlights. So in A, I will highlight the right border, this other side, and I will enhance its weight and color. So give it color red and enhance its weight like this. I'll do the same for B, then for C, and and then for D, then I will copy this kernel map here and paste it down here 3 times. The first kernel map will be the values of D out. I will have to fill in these values. So I have 0, 0, 0, 0. So that's going to be 0, 0, 0, 0. Then I will also have here 0, 0, 0, 0. So here I'll have 0, 0, 0, 0, like that. Then here I have 1, 1, 1, 1. So that is 1, 1, 1, 1. And this is also 1, 1, 1, 1. So then I center everything that I'm having here. So I can fill in the rest also. So here is 0, 0, 0, 0 for C out. So this is going to be 0, 0, 0, 0. Then I will have 1, 1, 1, 1 here. So this will be 1, 1, 1, 1. Then here I'll also have 1, 1, 1, 1. Then finally I'll have 0, 0, 0, 0. And I can center everything. So for manipulation of this, I will have to freeze some few cells. So I'll freeze up to row 18. Then I will come to this kernel map of B out and also fill it. So B out is 0, 0, 1, 1. So here is 0, 0, 1, 1. Then I will have 1, 1, 0, 0. So here is 1, 1, 0, 0. Then I will have 0, 0, 1, 1. So that's 0, 0, 1, 1. Then finally we have 1, 1, 0, 0. Then I'll also center align everything. So I'll come here and center align. Then I fill in the last kernel map. It's 0, 1, 1, 0. So 0, 1, 1, 0. Then I have 0, 1, 1, 0 again. So 0, 1, 1, 0. Then 0, 1, 1, 0. And finally, I have 0, 1, 1, 0. Then I will center align everything. I'll come here and unfreeze my frozen cells. So view, freeze no rows. Then I will create the logic expressions for these kernel maps. So the first kernel map is this one here, and it is the kernel map of D out. So its logic expression is going to be created by this group here that I am representing in green. And then it's going to be entirely in D. So that's gonna be D. And it's the only main term that we have there. In the second one, we have two groups. We have this group here that I've represented in green, and we have this group here that I've represented in purple. So the green group for this, C out, the green group is fully out of C, so that's C prime, and it is fully in D, so that is D. It is partly in the rest, so we don't care about A and B. Then we come to the expression of B out. So in B out, we have this group here, which is fully in B, so that is B, fully out of C, so that is C prime. And it is partly in A and partly in D, so we don't care about those ones. Then we have this group here that I am representing by color green, and that group is fully out of B, so that's B prime. It is fully in C, so that's C, and it is partly in D, so D is not our option, and A is also not our option because it's partly in it. So it's B C prime and B prime C. Then we've finished with that, so we make the logic expression for the last kernel map. So the last kernel map is the kernel map of A out, and the groups are two. We have this group here that I'm representing in green, and that group is completely out of A, so that's A prime. It is fully in B, so that is B, and it's partly in the others. And the other group is this group here that I've represented in that orange color. That group is fully in A, fully outside B, and it's partly in the rest. So for C out, this group here is C prime D, and then the next group is supposed to be the pink group. So this will be combined with an OR gate, and the pink group is going to be entirely in C, and that's why we have C, and it's fully out of D, and that will be D prime. So that is what we are having. Then we shall come and launch our software. I'll do a few setups here. I will come to layers and set up my instant and port labels. I'll come to view and set up my magnetic grid to 1/8 inch. Then I'll create some IP switches, in this case 4 of them. So I'll have 1, 2, 3, and 4. Then I'll also create some small inverters. So gets small inverter. So I'll have 1, 2, 3, and 4. I'll give them names. So this one will be D, and this will be D prime. This here will be C, and this will be C prime. This will be B, and this will be B prime. Then this will be A, and this one here will be A prime. Then I'll have to connect this to that, this to that, this to this, and finally this here will be connected to this. I want to do comparison to my spreadsheet document, so I will start implementing the logic. So I will have 6 two input AND gates, 1, 2, 3, 4, 5, 6, and then I will have one signal that is not being connected to any gate, and that's D. So here I'll create gates and 2 input AND gates. Right here I will have this as 1, 2, 3, 4, 5, and 6. So naming them from the first one here, which is C out, I'll have C prime D. Then I will have CD prime. Then I will have BC prime. And then I'll have B prime C. And A prime B. And AB prime. I will connect this to this, so I'll start with A prime. So A prime will be connected to this here, and it's the only A prime that I have, so I proceed to A. So A, I have this down here, and it's also the only A that I have, so I proceed to B prime. So B prime, I have this down here, and I also have this one right over here. And those are the only B primes that I have, so I proceed to B. So I add another wire segment, and the first B is here. Then I have another B here. And that is those are the only B's that I have. So I go to C prime. So I'll connect the first C prime is here. And the second B prime is up here. So I'll connect this. So those are the only sims that I have. So I go to D prime. So I have D prime here. And that's the only D prime that I have. So I move to D. So I'll come here and connect here. Now I also noticed that I didn't connect D, so C, so I'll add a wire segment here and connect this C here. So then over here, I also didn't connect this C. So this C here, I'll add a wire segment and connect this C. like that. So all my inputs have been connected. So on this other side, I just need to combine them using some OR gates. I'll create two input OR gates. So create gates, then two of them. So the first one will be here. So I'll have this, then the second one will be here. Then the third one will be here. The first one combines C prime D and C D prime. So this here and this are being combined in that way. Then BC prime is also being combined here with B prime C. And finally, A prime B should be combined by AB prime, combined with AB prime. So the name of this is C prime D or CD prime. The name of this is BC prime or B prime C. The name of this is A prime B or AB prime. Now I need to have some output LEDs this side, and I need 4 of them. So I'll create output LEDs and I'll have 4 of them here. So the name of the first one will be D out. The name of the second one will be C out. The name of the third one will be B out. And the name of the last one will be A out. So A out will be connected to that, just as here is A out is equal to that. Then B out will be connected like this. Then C out will be connected like that. And D out will be connected to D. So if you remember, you realize that D out was just a single signal, and therefore I'm going to create a wire segment from here and then connect it all this way up to here and connect that to the D out LED. I'll increase the size of this window and put it in full view mode. So that's how the circuit looks like. So we have to check for potential errors of this circuit. So I'll come to options and check design and highlight errors. So there are no errors found. So I'll say okay. And then I'll have to test for its working, if it's working correctly. So the first thing that I'm gonna do is to reduce this window here so that I cross-check it with my truth table. So I have to test it. The first one is 0, 0, 0, 0, so that's 0, 0, 0, 0. This other side is also 0, 0, 0, 0. I'll do some random checks. just to save on time. So this is 0001. So 0001. This other side also gives 0001. Then I'll also check this here. 0010. On this side it gives 0011. Let me check 10. This one here. So this is 1010. So 1010, and all of them are late, just the same way as here is also 1111. And final check, let me check the last one, which is 15. 1111 here, 1111 gives 1000, and that's what we see here. So I'll just create its sub design, this one here. So I'll first begin by saving it. So Control+S, and I'll save it in its own new folder. So, and that folder will be gray code decoder. So this gray code decoder, the name of the circuit is, it's a decoder. So I'll just call it a decoder. Then I'll save it. Then I'll come here and create its sub design first by creating a symbol. So I'll come to edit, then I create the symbol of this circuit. Then I'll come to file and new. So over here, I will check my instant labels and port labels. Then I come to magnetic grid and change it to 1/8. I'll right click this space and create a sub design, and it's for this decoder. So I'll put it here. And on this side, I will create hexadecimal switch here. And this side, I'll create an hexadecimal display. So this, I can combine it with this like that. And then these ones can also be combined to this display like that. So that's what we are having, and I can test the values of my decimal numbers against the gray code, the equivalent gray codes. So if you come to 0, the gray code of 0 is 0, the gray code of 1 is 1, the gray code of 2 is 3, the gray code of 3 is 2, the gray code of 4 is 6, of 5 is 7, okay, of 6 is 5, of 7 is 4. We can test 10. 10 is A, and we found that the gray code was the total, which was 1111. In this case, it's supposed to be F. So if you test A is F, and if you test F is 8. So that's how it works. So this one is the tester circuit for our gray code decoder. So if you enjoyed watching this video, give it a thumbs up. Consider subscribing for more upcoming content, and I hope to see you in my next video. Thank you.